In question 3, we are told that we have a stationary object O that is acted upon by 3 separate forces. We have a 4 Newton force and we have a 5 Newton force over here. Now, we are asked to find what is the value of force X. Okay, so because this object is stationary, we must understand that this object is in equilibrium. And for an object in equilibrium, the vector arrows, the vector diagram, must form a closed loop, right? All 3 forces must form a closed loop. Okay, so if let's say we start off with our 4 Newton force over here, let's redraw him. Okay, we got a 4 Newton force over here. Okay, then we have to draw in a 5 Newton force. So our 5 Newton force acts roughly diagonally this way, 5 Newtons. And we are going to have some force X that acts vertically or horizontally towards the left. Okay, and by Pythagoras theorem, I think we can more or less deduce that this is going to be 3 Newtons. Alright, because we have 5 squared minus 4 squared, and then we square root to give us 3 Newtons. Okay, so the answer for this is B. But let's say it didn't occur to you to use Pythagoras theorem. Alright, how would we otherwise do this particular question? Okay, we already know that for these 2 forces, 4 Newtons and 5 Newtons, alright, the maximum force that we can get, okay, the max force between 4 and 5 is going to be equal to 9. And this can only occur if the 2 forces are aligned in the same direction. Okay, and we have the minimum force between the 4 and 5 Newton is going to be 1 Newton, and this will only occur if they are acting in opposite directions. Okay, where 5 Newton perhaps is acting right and then the 4 Newtons is acting left, so we're going to have a resultant of 1 Newton acting towards the right. So this means that X will have to act 1 Newton towards the left to cancel off this resultant force due to 5 and 4. Okay, so as such, we know that C and A cannot be our answer, and definitely D is also out because it's more than the maximum force of the 4 and the 5. Okay. Now, A and C definitely are out because you can see very clearly that these 2 forces are at an angle to each other and they are not in the max or minimum configuration. So by elimination, our answer is still going to be B.